So suppose we have a function f of x equals x squared minus 1, that quantity, divided by x minus 1. And we want to find the value of this function at x equals 0. The most obvious way to do this is to simply substitute the value into the function. F of 0 is going to equal, in the numerator, 0 squared minus 1 divided by 0 minus 1, and negative 1 divided by negative 1 is positive 1. The question that might come up is, would values very close to x equals 0 yield outputs very close to 1? So at 0 we've already got 1. What if I put in negative 0.1 or positive 0.1? Well, if I put in negative 0.1, I get out for f of negative 0.1, 0.9, and for f of 0.1 I get 1.1, which are indeed pretty close to 1. If I put in negative 0.01, I would get out of the function 0.99, and if I put in positive 0.01, I'd get 1.01, which again is very, very close to 1. In fact, as I get closer and closer to 0, so either negative 0.001 or positive 0.001, I see the values that I'm getting out of this function are getting closer and closer to 1. In this case, 0.999 and 1.001. And I think you would expect in this case, as I put in things closer and closer, I put in more and more decimals in each one of these on the positive and negative side, I'd get things out. One side would be slightly below 1, one side would be slightly above 1, but we'd be getting closer and closer to 1. So yes, indeed, as we get closer to x equals 0, we get outputs that are very close to 1. If we want to indicate this behavior in calculus, we have a special way of writing this. We use the term limit, which is abbreviated by the word LIM, to indicate that we're getting inputs closer and closer to some value. The fact that as we got closer and closer to 0 from the left-hand side, so x approaches 0 from the left, that's what that negative means, of this function, well, we got closer and closer to 1. If I want to indicate that we were getting closer and closer to 0 from positive values, or from the right-hand side, I'd write the limit as x approaches 0 from the right, so the little plus here indicates that I'm coming from the right-hand side, of that function is equal to 1. The idea of a limit is we're getting closer and closer to some value, and that's always written down here below. So the way I would write this out is I would say as x approaches 0 from the left, the value of the function approaches 1. So the left comes from the fact that we're dealing with the little negative there. On the other hand, as x approaches 0 from the right, the value of the function approaches 1. So the 0 with the plus there indicates that we're approaching from the right-hand side. Each of these are one-sided limit, and they describe the behavior of the function near a point. We would write out what we see here, and so each one of these, because we see this little plus and this little minus, those are one-sided limits. And if these one-sided limits are equal to the same number, in this case positive 1, then we indicate this with a two-sided limit. And when you see the two-sided limit, you don't see anything up next to that 0 anymore. That means that from the left and from the right, both of those were equal to the same value of 1. For the two-sided limit to have a value, each one of the one-sided limits must equal the same number. Notice that in this case, the value of the limit was the same as the number that you get when you put in x equals 0. This isn't always the case. For the definition of the limit of a function, let's let f be a function and let a and l be real numbers. If as x takes values closer and closer, but not necessarily equal to a on both sides of a, the corresponding values of f of x get closer and closer and perhaps equal to L. And 2, the value of f of x can be made as close to L as desired by taking values of x close enough to a. Then L is the limit of f of x as x approaches a. Basically what we're saying here is as we get closer and closer to this value a, that the value that we're getting out of the function is getting closer and closer to L. And if you want me to be within some amount from L, I can pick a value over here for a that accomplishes that. So now let's change the problem slightly so that we can find the limit as x approaches 1 of f of x. What's that limit? You might think we might be able to cut some corners and just put x equal to 1 in the function, because remember, the two one-sided limits last time were the same as when we just plugged in 0. But we do run into a bit of a problem here. When I go ahead and do f of 1 here, I get 1 squared minus 1 divided by 1 minus 1, and my big problem here is I get a denominator equal to 0. And we can't divide by 0. So this is just simply undefined. So since this makes no sense, we have to fall back and we have to go ahead and construct that table again. We're going to have to go ahead and figure out what the limit is as x approaches 1 from the left, so that's why you see the negative there, and we need to do the limit as x approaches 1 from the right. So I'll construct a table with values getting closer and closer to 1 from the left-hand side, and values getting closer and closer to 1 from the right-hand side. When I put 0.9 into my fraction, I get 1.9. When I put 1.1 into the function, I get 2.1. Now, if I put in 0.99, a little bit closer to 1, I get 1.99. And if I put in 1.01, I get 2.01. It looks like we're getting closer and closer to 2. But let's check by going a little bit closer. So when I put in 0.999, I get 1.999. And when I put in 1.001, I get 2.001. So what it seems to indicate is the closer I get to 1 here, the closer that the value of the function is to 2, but at 1 it's actually undefined. What we'll write is the limit as x approaches 1 from the left of f of x is 2. The limit as x approaches 1 from the right of f of x is also 2, but it's undefined at x equals 1. How this happens is, let's take a look at this particular function, f of x equals x squared minus 1 divided by x minus 1. It's undefined at 1. That's why you see the open circle here. But when I look at the graph, it's just a straight line. And the closer that I get to 1, the closer that I get to 2. Even though at 1, it's undefined because of the open circle.